Okay, 3.2, solving linear systems algebraically. The first method we're going to talk about is substitution. So the first step one is solve. You're going to solve one of the equations for either x or for y. It doesn't matter which one, you're just solving it for one of those two things. Step number 2 is substitute, and step number 3 is also substitute. We're going to substitute an equation into an equation, and then we're going to substitute an answer back into an equation. Okay? I have 4 on the board that we're going to work on, and then you're literally just going to do them for practice for fun. Now, here I have 2 equations. 2x plus 5y equals negative 5, and here I have x plus 3y equals 3. If I want to solve one of those equations, because that's step 1, which one do you think I should solve? The blue or the pink?
The pink.
And for what variable?
For y.
Okay. I'm going to solve the pink, but I'm going to solve for x, because then I don't have to divide and have fractions. Does that make sense?
Mm-hmm.
Try to stay away from fractions if you can. So if there is a variable that only has, that has got a leading coefficient of 1, let's solve for that. Okay? So this equation would simply be rewritten as x equals negative 3y plus 3. Yes? Does that make sense? Okay.
Oh, wait.
What?
I thought that it was supposed to be y equals
No.
x.
I just explained that. Listen. When you're doing linear systems solving algebraically, you can solve for either x or y. It does not matter which one. I suggest you always solve for the one that has a 1 as the leading coefficient. Okay? Because it will make no fractions and it will make it easier. Does that make sense?
Yeah.
Okay. If you are graphing, if you're solving linear systems through graphing, yes, you have to put it in y equals form. Okay? So here, what I'm going to do is I'm going to take this equation and I'm literally going to plug this whole equation into the x of that equation. So if I write this, and I do this in 2 colors because I think it helps me see it better. So I'm going to say 2 times negative 3y plus 3, okay, plus 5y equals negative 5. Okay. Now I only have one variable in this equation. Do you see that?
Yeah.
That's what we're going for, one variable. From here, what do you think I need to do? Distribute. So I say 2 times negative 3y, which is negative 6y, and 2 times 3, which is positive 6, plus 5y equals negative 5. Now what do I need to do?
Subtract 6.
Do the what?
Subtract 6.
Subtract 6 from both sides. Okay. So I get negative 6y plus 5y equals negative 11. Now what do I need to do? What is negative 6y and positive 5y? So negative y equals negative 11, and I divide by negative 1, and you get y equals 9. That's my answer for y. Now, I have to, again, substitute. I'm going to substitute this back into any of these equations. I'm actually going to just substitute in here because this is already in x equals form. Okay? So I'm going to take this and substitute it in for that y. So that you get this. You get x equals negative 3 times 11 plus 3. What is negative 3 times 11? So x equals negative 33 plus 3. So what does x equal? Negative 30. Now, when you write your answer, they're going to have you write it in an ordered pair. So you're going to write your answer to say negative 30, 11 in ordered pair form. Okay? That's how they're going to show your answer in the book. Because what you're doing is you're solving that system instead of graphing, because would this be hard to graph?
Yes.
Yes. Okay, that would be a very large graph. Or I'd have to count by 5s or something like that. Okay? So instead of graphing it for these large ones, we're going to solve it through substitution. Okay? Walk me through this. What's my first step?
equals
Yeah, x equals -5.
Yeah, good.
-5y.
X equals -5y minus 9. Now what do I do with this?
plug in.
Plug it into that x. Okay, so I get 4 times -5y minus 9. And then I get plus 3y equals -2. What do I do from there?
Distribute.
Distribute. What is 4 times -5y?
-20y.
-20y. What is 4 times -9?
-36.
-36. Plus 3y equals -2. Now what do I do?
Subtract, or
Add
add 36.
Add 36. Good. Add 36. And I have -20y plus 3y equals 34, right?
Yes.
Now what's -20y and positive 3y?
Is 17.
So I get -17y equals 34. Now what?
Divide by 17.
And y equals
Give to.
-2. What do I do with that? Plug it in there, right? So you get x equals -5 times -2 minus 9. What's -5 times -2? And what's 10 minus 9? So x equals 1, and what do I have to do with that?
Order pair.
Order pair. So I'm going to say 1, -2, right? There's my solution.
We have to check those or some of them, or we won't have to.
If you do have to check them, which you probably won't have to, but if you do have to check them, you're gonna just plug them back into these original equations. Okay, that's all you have to do. Now, blue and pink, what do you wanna do?
Do x equals 2y plus 4.
X equals 2y plus 4. I'm going to take this and I'm going to
Plug it into x.
plug it into that x. So I get 3 times 2y plus 4 minus 6y equals 8. Okay. Distribute. 3 times 2y is,
6y.
and 3 times 4 is.
12.
Okay, now what?
Subtract that.
And I get 6y minus 6y equals, what happens here? So I get 0 equals -4. What's wrong with that?
Doesn't work.
It doesn't work, so the answer is
No.
no solution. So, remember how when we looked at the graphing where they cross once? This is like when they cross once, when you get an ordered pair. When they didn't cross at all, this is this situation.
Okay.
That's the no solution, okay? What about this? Let's try this one. What are we gonna do?
-4.
It's gonna be y equals,
positive 4.
yep, 4x.
Plus 3.
Take this and I plug it into the y. Good, because I stopped for a y on this one. So I get 12x minus 3 times 4x plus 3 equals -9. Now, I simply distribute, yes. What's -3 times 4? -12x. And -3 times 3 equals -9, right? Now what do we do?
Add 9 to both sides.
Add 9, and I get 12x minus 12x equals, so I get, what's that solution?
Infinite.
Infinite.
Oh.
It's when the lines are on top of each other. That wasn't right at all. Okay? So, you have three different types of solution. You can get an ordered pair, you can get no solution, you can get infinite solutions. The fun things about no solution and infinite solutions is it's less steps. Okay? If you get an answer for X or for Y, then you have to plug back in again and solve. That is what you're going to focus on tonight for homework.
So there's no graphing.
No graphing. It's solving completely algebraic.